Okay, on this lesson we're going to be looking at quadratic and square root relationships. So we just talked about cubic and cube root. Now we're going to look at quadratic and square root. So on quadratic and square root, inverse relations interchange your x's and y values. So we've already talked about that with inverses. So you're just interchanging, so just switching your x's and y's. This results in the domain and range of the inverse functions also interchanging. So your domain and range are just switched whenever you have your inverse. So the domain of the original function becomes the range of the inverse function, and then vice versa. So the range of the original becomes the domain of the inverse function. So with square roots, if you think about the square root graph, that's only half of a parabola. Remember, a quadratic is a parabola. A square root is just a ray. It has an endpoint and it continues on. So there's going to be some domain restrictions, which means you only want to graph a piece of your parabola in order for it to be an inverse of your square root. So domain restrictions may be used to ensure that the original function and its inverse are in fact inverses of each other. Okay, so we're going to have some restrictions. So it says find the inverse of this quadratic, but use this domain restriction, which means only use x values that are less than or equal to 0. You're going to graph the function and its inverse on the same grid. So first thing I'm going to do is I'm going to rewrite my f of x as y. And then I'm going to switch my x and y. I'm looking for my y, so I need to subtract 3. So I get x minus 3 equals y squared, and then I have to take the square root of both sides. Now remember, whenever you take the square root of both sides, you get 2 answers. But in this case, we are only wanting, remember, your domain becomes your range of the inverse function. Okay, so here's our domain of the original, so it's going to become the range. So our y values have to be less than or equal to 0, which means we're only going to be looking at the negative square root. So I'm going to have inverse, change it back to inverse function notation, and then negative square root of x minus 3. All right, so we're going to graph. So I'm going to graph the original. It's a quadratic, so it should be a parabola, but remember, we're only graphing the x values less than or equal to 0. So if you don't remember a quadratic, it's normally at 0, 0, which is your vertex, but notice right here your transformation would be going up 3. So I need to shift it up 3. And then normally my points for quadratic, if you don't remember, you plug in a -2 and you get 4, a -1 and you get 1, 0, 0. We could continue on, but we only want x values that are less than or equal to 0. So I'm going to go left 2, up 4, 1, 2, 3, 4, from my new point, and then left 1, up 1. So we're only graphing that part of it because of this restriction here. So now I need to graph the inverse of that. So I'm graphing the square root. So using your transformations, that part means that there is a reflection over the x-axis. And then the x minus 3 inside means it's going to go right 3. So our square root graph is normally the endpoint's at 0, 0. So I'm going to shift it right 3. But instead of it being right 1, up 1, it's going to be right 1, down 1 because of the reflection, right 4, down 2. So you have to remember your parent function values. I'm going to label it. And then this was my f. Now, remember when we discussed inverses? Remember, inverses are a reflection over the line y equals x. Which is this line. And notice that it's a mirror image across that line. Okay, so let's find your domain and range. Domain of the original, it was given to us. So you can either write x is less than or equal to 0, or you can write negative infinity to 0. I'll accept both. So that was given to us. The range, if you look at the y-axis and look at the purple graph, it's starting at 1, 2, 3, and it's going up. So you can either put 3 to infinity, or you can put y is greater than or equal to 3. Looking at the pink one, our inverse, the domain, notice it's at 1, 2, 3, and it goes to infinity, or you could put x is greater than or equal to 3. And then the range is going from negative infinity, and then it stops at 0. Or y is less than or equal to 0. Notice right here, we said at the beginning, your domain of your original becomes the range. Notice it is. And then your range becomes your domain of the inverse. So notice those are the same. Okay, you're just flipping them, interchanging them. Okay, so it is not necessary to write a domain restriction for a square root function because it's obvious from its graph. So we know the square root function is only half of a parabola there. So that's why we had to only use this negative piece in order to match this domain restriction on the original. Okay, let's take a look at the next one. So this one we have a square root. So there's no domain restriction on that one because remember it's just array. It has an endpoint and array or a continuous line. So we're going to rewrite. And then we're going to switch our x and y to find the inverse. So I'm going to subtract 4. We just talked about in order to get rid of a square root, we are squaring both sides. And then we'll just leave it like that, so that way we can graph it. Okay, so we need to graph our original here. So my square root graph. So notice it went up 4. 1, 2, 3, 4. And then my points are the same for my square root. So right 1, up 1, right 4, up 2. So that's my original. So my quadratic, remember, we're only going to need half of it. So we need to figure out where that is. So remember that your domain restriction is going to really be the range of this original. So let's go ahead and find these two. So the domain of this is from 0 to infinity. And then the range of this is from smallest is 4, and then it goes to infinity. Or you can put y is greater than or equal to 4. So there's going to be my domain, because remember the range of the original is the same as the domain. So there's my domain restriction for this one here. So my x needs to be greater than or equal to 4 when I'm graphing it. Okay, so when I graph this one, I forgot to put in function notation. Transformations are the same as any others. So inside we would be shifting horizontally. So we're going to the right 4. And then we are graphing all of the x's that are greater than or equal to 4. So I'm going to go to the right. So normally on the parabola we go right 1, up 1, right 2, up 4, because we're squaring. So that is my inverse. So you're only graphing half of that parabola because remember, here's my square root graph and it's only half of it. So you have to have a domain restriction on the parabola one in order to match your square root graph. So let's find the domain. We know the domain is going to be 4 to infinity, or x is greater than or equal to 4. And then the range is going to be 0 to infinity. So again, your domain and range switch on your inverse. Okay, let's get the back. So we're going to find the inverse f algebraically. So I'm going to rewrite it, rewrite it with a y, and then I'm going to switch my x and y. So in order to get y by itself, I'm going to have to take the square root of both sides, which means I need a positive and a negative answer. But notice that we only want positive values, so make sure that you're only using the positive square root of x. And then when we subtract 5, we get square root of x minus 5 equals y. So inverse of f is square root of x minus 5. So we only want the positive one here because of our domain restriction on our original. So there's my inverse graph. Okay, looking at the next one. So again, I'm going to rewrite f of x as y. And then I'm going to switch the x and the y. So I'm going to divide to get rid of the negative. And then I square both sides. So that becomes x squared equals y minus 2, and then I need to add 2, so I get x squared plus 2 equals y. And then changing that to function notation. Now, on the quadratic ones, you need a restriction here. So notice that we were only getting negative y values here, which means my domain would be only negative values. Okay, so less than or equal to 0. So there's my function. So remember, you only need a domain restriction on your parabola, because on a parabola quadratic, remember your square root graph is only half of that. All right, let's look at another one. So we're going to rewrite f of x as y. We're going to switch our x and y to find the inverse. So we get x minus 6 equals y squared, and then we need to take the square root of both sides. When I take the square root of both sides, I need a positive and a negative. Now, remember, looking at your domain restriction, that means your y values have to be less than or equal to 0 because it's interchangeable. So since they have to be less than or equal to 0, I only want the negative version. So I'm going to have f inverse of negative square root of x minus 6. So if you have a domain restriction, you're starting with a quadratic, you will have to look at your square root closely to determine if it's going to be the positive square root or the negative square root to only get your half of your parabola. All right, we're not doing number 4. The last part, we're verifying if they're inverses using composite functions. So remember, we've talked about this before. We're just plugging one into the other and then vice versa to make sure that it equals x. So I'll take the first one, plug it in. So that's going to be square root of x plus 10 squared minus 10. When I have a square root, I square it, it gets rid of it. So I have x plus 10 minus 10, which gives me x. That one works. And then doing the opposite. Now I take this one, plug it in for this x. So I have g of f of x. I have a square root. In place of x, I'm putting x squared minus 10, and then I have the plus 10. Notice the 10's cancel, square root of x squared equals x. So yes, these are inverses of each other. Excuse me. So remember, composite functions, you take one function, plug it into the other, and then vice versa to make sure that it gives you an x. If it gives you an x, that means they're inverses. So let's try another one. I'll take the g, plug it in here. So I have square root of 2 parentheses 2x squared minus 1. and then I have a plus 1. So underneath the square root is going to give me 4x squared minus 2. I know that is not going to give me an x for the final answer. So I know that that is not going to be inverses. They both have to equal x. That's not going to give me an x, so I know that I don't have to go any further. All right, last one. So take this one, plug it in for x. All right, so looking here, I have a square root and then it's squared, so that just leaves me with x over 3 because it cancels each other out, times 3. So notice the 3's cancel out and you just get x. Now doing the opposite. So I'm going to have I'll have 3 square root of x on top over 3 and then squared. The 3's cancel, so I have square root of x, but I'm squaring it, so it gets rid of it, which equals x. So yes, these are inverses. Okay, so that's using composite functions. So really, we're not really even paying attention to the domain restriction when you're just verifying if they're inverses of each other. If you have any questions, please let me know.